Hello Internet. In this video we are going to be generating, compiling and running some stable HLO code, and we are going to do that using JAX. Now stable HLO, as you might know, is a bunch of high-level operations that a lot of machine learning frameworks are capable of generating. TensorFlow can, so can PyTorch, and so can JAX. And in this video we are going to be sticking to JAX. So let's get started. I'm going to import JAX and create some data. I'm going to create two JAX arrays now and put in some random data here. Okay, our data is ready, and now we are going to be multiplying these two arrays, but we are going to be multiplying these as matrices. So let's create a function called mathmul, which takes two inputs and returns the product of those inputs. We of course need to transpose the second argument because that's how matrix multiplication works. The result is going to be a single value, as you might have guessed. Okay, so this is good. And now we are going to be converting this mathmul function into stable HLO code. And how are we going to do that? Well, we start by defining the types of the arguments this function takes. So we already know that the D type is int32, but what is the shape? Okay, the shape is 3, Now let's create a variable of type jax.shape dtype struct and say that the shape is 3, and the D type is jax.numpy.dtype int32. Okay. Now that we have this, we are all set to generate some stable HLO. Yeah, so the first thing we need to do is call the jax.jit function and pass mathmul to it. This returns a just-in-time function which needs to be lowered. So let us lower it. Okay, now lowering is an operation that moves the function from Python to a lower representation, a representation that any ML compiler understands. An ML compiler like OpenXLA or IREE. And the arguments you need to pass here are the shape dtype structs of the arguments that the actual function receives. So I'm just going to say data info, data info here. Okay, now we have a lowered object. And at this point, we can already see the stable HLO code by calling its asText function. And this is the stable HLO code we just generated. We could pretty print this. I think I'm gonna pretty print this just so you can take a better look at it. So I'm gonna import pprint and create a pprinter. Pretty printer. There you go. So yeah, this makes much more sense. We have a main function and we are returning a single i32 value. And yeah, the rest of the code you don't need to understand because you're not meant to be seeing this anyways. But now we need to compile this function to be able to run it. So I'm going to compile it and assign this to a variable called matmul_c. Okay, good. So what is this? This is a compiled object, and this can take our arguments a and b, and it returns the value we expected. So now you know how to work with StableHLO, how to generate it, how to compile it, and how to run it. Great. I hope you found this video useful. Please like and subscribe.